Hello, everyone, and welcome at Sempergreen Academy's first webinar at this rainy day in the Netherlands. We're excited that you've decided to join us today. We're here at the studio of InfoPlaza. InfoPlaza is a weather company headquartered in the Netherlands. They collect and analyze complex global weather data, which they translate into understandable reports for their stakeholders. Before we kick off, I have a few household notices for you. So firstly, as you've noticed, we've muted your mics. Please keep those muted during the whole of the webinar. Secondly, we will record this webinar so we can share it with you at the end of the session. And thirdly, if you have any questions during the webinar, please ask them in the chat so we can answer them at the end of the session. Let's have a look at the agenda for today. First, I will talk a little bit about Sempergreen Academy and our speakers. Next up, Roosmarijn Knol will talk about the causes of urban flooding from a meteorological point of view. Then Dr. Anna Zackerson will talk about the solutions to urban flooding from a scientific point of view. And at the end of the webinar, there will be a Q&A where Anna and I will answer all your questions. My name is Stefan Berends and I'm Director of Sempergreen Trade within Sempergreen Group Worldwide. We are global. Hello. Lots of projects that we've done in Europe. It's our mission to create a greener and more livable world, and knowledge sharing plays a vital role in achieving that objective. The reason is that without information in the right place, we cannot move forward. So therefore, we've decided as a company to partner with experts to be able to share relevant content regarding green solutions and other topics through Sempergreen Academy. One of these experts is Dr. Anna Zackerson, and she is the Vice President of European Affairs for the Green Roof Diagnostics. She's a creative and award-winning scientist that translates difficult scientific information into understandable language, making the wonders of science available to everyone. It's her mission to inform and to communicate and to push projects forward based on solid data. And this comes from a vision of a flourishing green industry that bases its claims on scientific data. In short, she is a consultant, an independent consultant that always lets science have the last say. But before we listen to what Anna and what science have to say about urban flood prevention, first, Roosmarijn Knol, who is a meteorologist at our host InfoPlaza, will tell us all we need to know about the causes of urban flooding. So sit back, relax and enjoy, and I give the floor to Roosmarijn.
So hello, everyone. Before we continue to Anna her talk about the impact and the design of green roofs, I'm first going to talk a bit more about why we actually need these green roofs. Because we are currently living in a changing climate, and this means that our weather is changing. And that can go in two ways. We can have a shortage of water, so that means droughts, and a deficit of water, but we can also have a surplus of water. And that's what we see over here, and that is urban flooding. So in this changing climate, we are dealing with an increase in temperature. And that increase in temperature means that the atmosphere can contain more moisture. And the increased amount of water vapor and moisture in the atmosphere means that rainfall events will become more frequent, but also more severe. So we need to change the design of our cities to deal with these increasing amounts of rainfall. So here I have a graph that shows how the amount of water vapor in the atmosphere changes when the temperature is increasing. Here we can see the amount of water vapor when the air temperature is 20 degrees, but here we can see how that increases, almost doubles when we go to 30 degrees. So an increment in temperature can already have a huge effect on the amount of water vapor that the atmosphere can contain. And this is a prediction for some major cities in the world, not only in Europe, but all over the world. We can see that the temperature increase in the warmest month of the year varies between 1.9 degrees Celsius up to almost 8 or 9 degrees in the warmest month of the year. So almost a 10-degree increase in temperature, as we saw in the previous slide, can have a major effect on the intensity of extreme rainfall events. So recently we saw an example of such an extreme precipitation event that had a heavily disrupting effect on big parts of Germany, Belgium, and the Netherlands. As you can see over here, roads were flooded, cities were flooded, and that has a huge impact on societies. So where does that extreme rainfall event come from? So the atmosphere can contain moisture, but what makes such a rainfall event so extreme? Here we can see the jet stream. The jet stream is a meteorological phenomena, and when the jet stream is a straight line, that means that the air and the wind at a higher altitude is flowing in a more or less straight conveyor belt from west to east. But when the jet stream becomes disrupted, as we can see over here, when it gets a wavy pattern, that means that weather systems can become trapped in between the curvature of the jet stream. And that is what happened over here. We can see a low pressure system, a depression with showers and rain trapped in between the curvature of the jet stream. And that means that the showers remain at the same place for a long amount of time. And that means that those showers can produce extreme amounts of rainfall. And that was the case for the floods in Germany, Belgium, and the Netherlands. So here I have a map of the rainfall amounts. It was spread over 2 days. We can see here the 13th of July and the 14th of July. And this map shows the colors and the rainfall that was measured during those days. So we can see the blue, purple, and red colors. So in one day, the maximum amount of precipitation was 150 millimeters. But when we add those 2 days together, you can see that the total amount of precipitation in this area, a huge part, added up to almost 200 millimeters. So that is an extreme amount of precipitation, and our current infrastructure is not ready to deal with these amounts of precipitation, and that leads to severe flooding. So this was an event, a very rare event that happens in once every 400 years. But science has shown that these type of extreme events are more likely to happen in the future. And in summer, it is up to 9 times more likely that such an event will occur. And as we saw in the previous slide, the extreme amount of precipitation, so almost 200 millimeters, can even increase with another 3 to 19%. So we should prepare ourselves for more of these extreme events. And here we can see what happens when these extreme amounts of rainfall are falling in these areas. You can see the water flooding over the streets. It's taking cars and trash cans with it, leading to huge amounts of damage, economical, but also for the societies living there. They can see their properties being damaged. And as you can see in this video, this is a video from Scotland, you can see that the houses, the infrastructure is not able to deal with the extreme amounts of water and breaks down. So we need to find new ideas, new designs to come up and deal with these extreme amounts of precipitation. And Dr. Anna Zachrisson has some of these very new, creative and innovative ideas in the form of green roofs. So I'm going to give the floor to Anna, and she will tell us a bit more about it.
Thank you, Rose-Marie, for the introduction, and thanks for the invitation to present some of Green Roof Diagnostics research. So yeah, I'm Anna Zachrisson, and I work as a biologist, but a very water-focused biologist for an independent green roof institute located with headquarters in the US. I am located in Berlin here in Germany, however. So I would like to just start with saying, just like Rose-Marie did before me, we have a massive urban problem. We have impervious surfaces And we have disrupted the natural water cycle. We have increased heat island effects, increased pollution. So why does this matter? Well, it matters because 60% of the world's population live in these urban areas, and the trend is increasing. This is a massive economic, ecologic, health, and societal problem that we must deal with today. So a dysfunctional urban water cycle basically means that we have sealed all the surfaces. There's no way that water can, or it's very reduced way that water can be percolated into the ground and reach the groundwater. So not only does this lead to flooding events like you see in this picture, but it also leads to problem with the replenishment of the groundwater, which can lead to further problems down the line. So we really need to take a good look at this, and we cannot wait until tomorrow. So now, the natural water cycle. Let's start with that so that we understand what it is that we're actually trying to recover. So there are two processes. One process you can see here. It is basically the evapotranspiration process in which the water is released into the air as vapor. The plants take up the water through the roots, and through the evaporation process and the transpiration process, the water is basically sucked from the ground and returned to the sky. Now, this process cools the area. So if you go into a lush green forest, you will always find it much cooler than the asphalt street or even the meadow next to you. So this is because of this very intensive process that trees are very, very good at, and plants in general, of course. The other process we have here is what happens with the water that is not directly evapotranspired. So if it rains enough, that some of the water is transpired, some of it is sucked up in and immobilized to the ground, but some of the water will be in excess. So it will trickle down through sticks and stones and a slow process. And through this process, some of it will continuously percolate into the ground. Eventually it might reach a small stream. But this whole process is slowing the water down. This is the detention process that we will talk about with regards to green roofs and stormwater management later. So remember these two processes. Number one, evapotranspiration and retention process here. And then we have the slowing down process, the detention process for the remaining water. So one very important thing to remember is that we should always try to work with nature and not against it. So if we can install green areas in our urban areas and actually let the plants do the heavy lifting for us, remove the water from the ground and return it to the sky, or help us percolate it into the ground to reach the groundwater, it's always better to work with nature than against it. So this is why green areas in urban areas are such a splendid idea. So going up to the roof, when you have a bare roof, like you see here in this picture, approximately 100% of the precipitation will run off the roof annually and basically become runoff. And this, of course, if it's a big storm, it will fill up the sewers. It can lead to so-called combined sewer overflows. That basically is an overflow of the combined sewers that take in both what sewage comes from your toilet mixed with any water that comes from rainfall, basically. So these sewer systems are often underdimensioned in the Western world and can lead to an overflow. And in order for us to not have our toilets overflowing in our houses, there are so-called combined sewer overflow points, often located in the nearest water body. So now, as I sometimes say in Berlin, if it smells like poo when it's raining, it is poo, sadly. So this is something we would like to absolutely remove. This is not something we'd like. So the other process here on a green roof, you can see that you have 100% of the water coming down in precipitation, but around 70% of the water is evapotranspired annually if you have a high retention type green roof, mostly containing also needle mineral wool. But we still have this 30% annually in this particular case that will become runoff. Now, this is the water that is coming from large storms and from repeat storms and are the storms that cause the most problems and can lead to combined sewer overflows. So this has been a little bit what we've been most focused on see how we can handle that water that becomes runoff. So to just present our lab a little bit, that we of course are very proud of, the Green Roof Hydrology Lab, the main lab is located in Virginia in the US. And we have a fantastic team there that I love working with. And we have this rain lab here. It's a rain simulator where we can basically simulate different storms, intensity, duration, and so on. Then we have these outdoor platforms. The platforms are on lysimeters so that we weigh every single water drop going in and out so that we can create models and make predictions of what system would work like and so on. So this is also our weather station over here that basically provides us with a lot of weather data. So we conduct physical modeling, swim modeling, and we also have several online tools developed that you can use free of charge online. So if you're interested in any of that, just go to the Green Roof Diagnostics website and check it out. So one of our main research questions has been, how do green roofs handle large storms? We're talking about these massive large storms that causes these flooding, devastation, and combined sewer overflows. Because there wasn't a lot of research done on this, which why we thought it was very, very interesting to take a look at. So I already spoke a little bit about the combined sewer overflows. Here we see a combined sewer outflow point where basically the blended sewage is released straight into a water body. As an aquatic ecologist, I have been, it's been my job in several years to actually sample these points and see, what the nutrient loads are, and etc. So I've come from the other side previously in my career. But also not only combined sewer overflows and the ecological damage and economic damage they create, there's also these disasters happening that we need to find novel and sensible ways to deal with these. And of course, no single method would be the magic bullet that fixes all, but we need to take a look at what type of innovation is available and start a sensible transformation to a truly sustainable society. And that means also including all three pillars of sustainability: economy, society, and ecology. So it has to make sense from all these three perspectives for a solution to be valid. So we took a look as well about what happens then. Are there sticks and stones, so to speak, on the green roof? Can we actually delay the outflow of the water? Remember the picture I had about the forest? So you have the evapotranspiration process that releases the water as vapor. But what happens with the water that is running off? Do we actually have a delayed effect? Well, we found that for a green roof, it tends to work like a sponge. For a traditional standard green roof that has no detention capacity, i.e. the most of the roofs that are on the market right now, is basically if you're in your bath, you have a wet bath sponge and you put water on it, it almost immediately flows out. It becomes a pipeline through the sponge. One drop in becomes one drop out. So in order to visualize this a little bit further, we were very interested in looking at this properly in the lab, and we have conducted over 2,000 tests on this now in the RAIN lab and also on full-scale roofs. So here we see a graph where you see in blue here, the blue line, you see the precipitation. And then we checked out the runoff here from a 4-inch conventional traditional green roof, and we saw basically no delay, no significant delay. So when I say no significant delay, you can see that there is a small delay here. We started out with the soaked roof. That's very important, the soaked roofs. And this small delay here, it technically, I could say, yeah, we could show that there is detention capacity, but just let's rephrase this. And in the catastrophic events that happened here in Germany and in the Netherlands over the past months, what would a 3-minute peak outflow delay really have done to of a few minutes, but in real world scenarios, this matters very little. We need to delay water by a lot more, and we need to reduce the peak as well. We see no peak reduction here. We just see a tiny delay here. So then we had a lot of people telling us that we just need to have a thicker profile, because then you'll see there's a detention, the delay in the system, basically an outflow delay. So we tested an 8-inch system here, 10 centimeters. And also here, we found an insignificant outflow delay from the green roof. So we didn't give up here. We were very interested to see what we could do with this. So we started testing many different types of textile layers that we put underneath the green roof profile to see if we can generate an outflow delay, a detention effect. And here you can see, this is from 2017. We tested over 70 different textiles here. And you can see that we found several textiles here that showed promise, that both had an peak outflow reduction and a peak outflow delay. So, which is basically the key, the two key things we are looking for in a proper stormwater management tool. So, is the green roof retention? No and yes. It depends on what type of green roof you're looking at. There are green roofs with detention capacity on the market. So, and one of these concepts on the market is the purple roof concept, that basically became the concept that we had researched with the studies that started in 2017. And here is the textile that eventually ended up being the most efficient for this purpose. And it is a detention layer, we call it detention textile, it's manufactured by a German company called Brovatec. And what happens in this layer is a polyester layer with many small threads here. And all of these threads basically generate friction. So as the water is flowing through the detention layer, the friction generates turbulence. And the higher the head pressure, the higher the turbulence. Meaning the more it rains and the more the water rises in the profile, the slower it will flow out. We have now tested this many thousand times. And we have modeled it, both physically modeling and also our hydrologists have created a swim module for this, or adapted the already existing green roof swim module for this. So, and this little diagram here, I just wanted to show like what this is flow rate against head pressure. And for a traditional green roof, you can see here, there's virtually laminar flow as it flows out. But for this system, it starts here when it's very low with rather laminar flow, but then as the head pressure increases, the turbulence starts to increase. And as the turbulence increases, the water rises into the profile. And then you have a slow outflow, slow and predictable outflow. So here you can see what the profile looks like. First is the detention layer down here. Then we have a honeycomb reservoir here. And this honeycomb shape basically means that there is no lateral flow of water between these cells, the result is that the system can be used for sloped roofs as well. And above here, we have a needle mineral wool, and then there is a vegetation layer here. So what happens here, you have the gravitational water flowing through the profile, entering the detention layer, turbulence is created, and as the head pressure increases, it slowly backs up into this honeycomb reservoir. There's another thing with this detention textile that is very interesting. And you can see here, the black lines here and the little arrows here. As the detention layer empties out, and if there is a little bit of water left on the roof membrane, it's basically sucked up here passively from underneath the layer, the drainage layer, and into the profile, and then basically released as runoff or evapotranspired. So with this system, you'll actually end up having a very dry roof as well from underneath the green roof. So it's important to know also the different type of detention concepts that you can have on your roof. So the purple roof concept is what I've been discussing here, because that's basically where our research has been centered. You can use this, it's a very lightweight concept, and you can use it also on sloped roofs. But there are also other concepts, and blue-green concepts are also wonderful, in my opinion. These are often intensive roofs, so they're a lot heavier. They also require a completely flat deck. But the very, very good thing about them is that you can have rainwater harvesting underneath the profile. So it's basically a very, very nice concept if you're building something and the load requirements will allow it, and you have a completely flat deck. It's a very good solution. Blue roofs is basically the same as a green roof. It just doesn't include any plants, which means that you're missing out on all the good retention capacity, the evapotranspiration capacity. Well, you have some evaporation, but not the transpiration capacity. So one really important thing to not forget is what is a green roof in the eyes of a stormwater engineer? How do stormwater engineers see green roofs in general, based on the story that I have just told? What is the real world use case of this? So for stormwater management, the rules of the game. When you are a stormwater engineer, you need to make sure that the building that you are responsible for is safeguarded against flooding, or at least safeguarded to a certain extent of flooding. You might not plan a building for a 1,000-year storm event, but you often plan a building that it needs to withstand a 100-year storm event. At least that's often what's common here in Western Europe, with some exceptions. So the stormwater engineer will have to often ensure that the stormwater tools available on site will ensure a maximum that they stay within the maximum allowable outflow rates of often around 10 liters per second and hectare. Sometimes it's even required that every single drop of the stormwater is dealt with on site. It really depends on where you are, which municipality, and so on and so forth. So in order to do this, they will calculate based on a certain statistical storm, a so-called design storm. It is at least usually what happens. And this design storm has a certain shape, it has a time factor, and it also has a depth, how many millimeters it falls, basically. So when we talk about stormwater management, it's all about, here's the rainfall, it's about flattening the curve of the outflow. So we have a peak flow reduction and also a peak flow delay. So it's a little bit of what we learn here during the horrible Corona times that we have behind us. It's kind of the same concept. We need to flatten the curve for stormwater. So there are, of course, different types of storms. A storm is not a storm, and they're all the same. They are very, very, very different. So they can go from a small summer drizzle and to medium storm events here to these absolutely catastrophic microbursts that will cause a lot of damage and destruction. And so we need to take a look at what green roofs can do for all of these. So when it comes to these small summer drizzles here, they represent most of the events, of course. So about 50% of the annual volume are represented by about 80% of the events, whereas 20% of the events here represent 50% of the volume. So we have these massive downpours coming down here. So from like maybe here to here, if the roof is dry, a normal standard retention type of green roof will do really well. The problem is when the outflow starts here, then we need to have the outflow delay that I previously also mentioned, the sticks and stones. So going back to how the purple roof concept is sized. Going back to the design storm that I just mentioned. So the engineer, this is probably a Euler type 2 storm, which is often used in Germany. It starts at medium intensity, going up to peak here, and then going down, and then slowly leveling off here. So that is basically the storm distribution that is used. Then in this case, it is over 60 minutes. And I believe in most cases for a 100-year storm in Germany, it's calculated between 50 and 55 millimeters or liter per square meter. So you have all these factors to take into consideration when you basically size a stormwater tool. So in order to help out with the sizing of the tools and to see if the outflow rates are met, because you need to meet the maximum allowable outflow rate. In this case, I have assumed 10 liters per second and hectare. This is one of the tools that we have online. It's on the Purple Roof website. It's the detention modeler. You can request a login for this and play around with it. This is a 100-year storm. If we had an unmitigated runoff, it will land at 510 or 511 liters per second and hectare. That means that if we had a bare roof or a saturated traditional green roof, this is the water that will come out at the peak flow, which is a substantial amount of water in a very short period of time. So with this particular Purple Roof concept configuration, I could get it down to 7 liters per second and hectare as outflow rate. Another very important aspect to take into consideration is sheet flow. So you need to make sure that you set up the configuration of the system so that you do not get sheet flow during the storm event you're modeling for. Because what is the use of having the water neatly go down and through the detention layer if all the water is running from above the profile, which is of course something we would want to avoid. So in this case, the model clearly says that there is no sheet flow, and it also gives you how big of a percentage of the detention capacity that has been filled up. Just a little fun slide here, because I like to think of buildings as also on the ground, the whole project as a water ecosystem. So I think we need to move away from this thought of like, we have a green roof and then our thinking and our involvement basically ends there. So I think we need to look at it from the water drops perspective, from the top all the way to the bottom. And with our model that we are continuously also updating and developing, you can also create these treatment trains. So if we had rain coming down here, unmitigated, no treatment, just a bare roof, you'll find that a little bit will probably manage to percolate, maybe 8 liters per second and hectare. There's a lot of sheet flow that would flow all over the street and basically cause a lot of erosion and maybe economic damage, maybe health damage. And that's not what we want. And here's basically the groundwater. So with this treatment train, I have taken as an example here. I've started with a Purple Roof concept here. It's a sloped roof here. The rain is coming down. The water is being slowed down here, and it ends up on a sponge roof concept on another roof. So sponge roof concept is basically what we call a roof that basically has a high retention capacity, meaning they have included mineral wool. And it's very important to say also that it's non-toxic mineral wool. I would never, ever suggest that anybody uses any mineral wool that contains formaldehyde. There's a good solution from Knauf Urbanscape that has a needle mineral wool for these purposes. So the water continues its path down here to a blue-green concept. And this is maybe where people are sitting having their lunch, chit-chatting and whatnot. And here some water can be stored as well for later use by these plants. Maybe there's a little bit of a garden here going on. The water then continues its path down to a vehicular area and then down to the ground. And maybe then we manage to model it that way and build it that way that the outflow rate coming down here meets the percolation rate, which basically means that the water is going exactly where it should be going, refilling the groundwater in a safe, predictable, and good way, I should say. So I mentioned in the beginning that it's very, very critical that we do not only think about the ecological side of this. we also must think about the economic and also the societal side. The ecological side is pretty obvious based on what I just have mentioned, and the societal benefits of this too. Now, the economics always plays into it. But there's one thing with detention type green roofs that is really good when it comes to developing an ROI for the roof, because you can reduce a lot of other at-grade stormwater solution and instead manage your stormwater fully here on the roof. You can often free up space that you can use for other kinds of development that creates an ROI for the roof. So I'm using these tanks as an example because we have an example project in New York City where there's a lot of these tanks built underneath the buildings. And considering that New York City is as costly as it is a pretty fast thing to actually pay for the detention type green roof. So our vision as a research institute is, of course, to get rid of this old, outdated concrete infrastructure that is used for stormwater and then replace it with green solutions. So here's one really beautiful roof garden. I'm from Stockholm myself, so I've been to several fantastic roof gardens in Stockholm, and they make a lot of money as well because they have their pubs and the bars there, and you can sit and have a beautiful view over the city as well. And while you see bees and butterflies buzzing around you as well. So it's really beautiful. And I also want to be very clear with that, of course, no solution is a magic bullet. There are fantastic also at-grade solutions that are green stormwater management that should be seen as a treatment train connected to each other and not as competitors to each other. So thank you very much for your attention. And yeah, if you have any questions, I know that Stefan Behrens will come and join me just in a few minutes. I think here he comes. Hello, Stefan.
Hello.
Hi.
Thanks, Anna and Roosmarijn, for the enlightening talk. It's interesting and also a little bit scary to see that us humans probably never will be able to control the weather. So I think it's vital that we work together with nature and create a win-win for nature and for humans. It's time for questions. There are quite a few. So if we won't be able to answer your question, we will do it afterwards. So don't worry, there will be an answer to your question. And I suggest that we start with the first one. So I shall read it out loud. I was in the regions with flooding during the extreme weather. A significant part of the destruction was due to the fact that more and more infrastructure is located in the former riverbeds. As the video in the collapsing house showed in the presentation, how strong is the climate impact compared to the river straightening?
Oh, that is a tough question. Of course, this river straightening is a massive problem as well, on that we have rather arrogantly also constructed things where they shouldn't be constructed. So this is exactly one of those matters where I think it's important that we have different solutions that connect with each other. And of course, a green roof cannot solve the flooding of a river, of course not. But it can at least, if a whole city is covered with green roofs, which I think at least my vision is, with detention type green roofs, then I think we can have a large impact. Look at the city of Berlin or New York City, that has a big impact eventually, because the roof areas are huge. But to say exactly how much this climate versus river straightening, I'm not the right person to really answer that.
Yeah, it's a little bit outside of the scope of this presentation, but I think your answer is very, very relevant. I hope that answers the question to a certain extent in any way. Next question, or is it a comment? Promotion and management of the green roof is kind of difficult. I don't think we see it that way.
I'm not really sure that. I don't really understand the question, to be honest, because it really depends. I haven't been in some meetings where people have a lot of very. They have opinions about green roofs, and sometimes I can't even mention that I'm coming there talking about like green roof research. I have to say it's a stormwater management tool that also works as a green roof. because people shut down when they have green roof, and they assume greenwashing or all kinds of stuff, where there is a lot of really good valid data on green roofs. I know I work with it myself, so
and why do you think that people think that it's greenwashing? Why?
Well, I'm not really sure, but there are, of course, topics that have been traditionally labeled in a certain political direction often just get tainted by the politics behind it, and has very little to do with the actual science of it. And we saw that tragically when it came to the topic of climate change, how this topic has been hijacked and destroyed. Yeah. And this, I think, is just a political thing. And also the fact that there was a lot of scientific data lacking from the industry for many years, but it's been catching up.
Yeah. So the more reason for us to do more of these webinars and inform people of what it actually is. Okay, let's go to the next question. This is an interesting one, because I know that we're both working on this subject. So what do you think about combining green purple roofs with solar panel, strategically placed to reduce sun exposure just to the point that it's mutually beneficial? Solar panels seem to work better when evapotranspiration helps in the cooling.
Absolutely. I think this is one of the biggest tragedies in places like New York City, for example. I feel also in Germany that solar photovoltaic panels are pitched against green roofs, whereas I think the most sensible thing is to combine them. Absolutely. And there's no reason to not be able to combine a purple roof system with a photovoltaic system, because then you have a stormwater management tool that also brings you electricity, and the system, the green roof system, will basically cool it down for you. So, but of course, you know, a high retention green roof would work as well if you don't need the stormwater management on your roof. Yeah. So it's all about like, what do you need and what functionality do you need, and then check out what type of roof would be the perfect for you. So it's but the combination is blended. Yeah.
Great. Another one. Quite a few questions. Having buffers for reuse purposes underground may still make sense in combination with blue, green, yellow roofs, isn't it? From Julia Machado.
Well, yeah, with blue-green roofs, it depends on what type of blue-green roof you have, because there are certain blue-green roofs that will basically empty out before a storm, and then you might have a little bit of lower detention capacity, or you need to size something on the ground as well. So yes, but it really depends on how you design them and such. It really depends. You need to have a look at it from case to case basis and make some sensible decisions.
And do we have data on this already, or is that sort of a subject that we still need to?
Yeah, I think there's is the blue-green company here in the Netherlands called Metropole. I think they're doing quite a lot of research on blue-green roofs.
Okay. Yeah. Excellent. A question, I will mention the names as well, to make it a little bit more personal. So a question from Fanyua. I'm also doing the green roof, but I find it's not easy to let people accept. They worry about rain leakage, which is something we talked about recently. Yes. Yeah, exactly.
Yeah, it is a classic. It's one of those things that I feel like at one point this what I always think as an urban legend will stop, because if you look at a green roof, it's extremely protected. The hailstorms in Germany have increased substantially over the past years, causing a lot of damage to bare roofs. Yeah. So, and also a bare roof will get damaged by foot traffic. You drop a tool, you damage basically the roof, and you get a leakage. And it's honestly not particularly much more easier to find a leak on a bare roof compared with the green roof. And the green roof is all protected from all this physical damage that you can get. But also there was a study from Soprema that has been quite famous, where they took, they had a roof where they had split it into a green roof and a bare roof, and they looked at the roof membrane. And on the bare roof, it was severely damaged after 20 years. But on the green roof, it basically, they couldn't detect any damage to it at all structurally, which basically means that the roof membrane lifespan can be extended by, well, actually it's an unknown factor, because they don't seem to actually age that much. yeah, I think it's less worried about the green roof. And also there's a lot of these green roofs that you can just roll them up, and you find the leak, you fix it. And if you're super nervous, there are leak detection system. But then you should install them on a bare roof
but
as well.
Basically it's an extra protection layer for the roof. Well, that's clear. A question from Lao Lu. What is the lead time for green roof orders of typical residential developments?
That's maybe something for you to answer rather than me, because I don't work in sales at all.
No, but I would, but this is something this can be done in quite a short time. So in a matter of days, we should be able to process an order, and it's very easy to lay on the roof. So I would say from a week up to a few weeks, you can already order and lay the roof on your house or wherever you want to lay it. So it's really easy. Yeah. Question from Julia Machado. The benefits for the government, municipality are visible. What are the benefits for an investor? Is that?
Well, that is basically going back to the ROI.
Yeah.
So the municipality, it's obvious. You get less water to treat in the sewer systems, and you get less flooding and so on.
Yeah.
But what happens, like if you're an investor, let's say that you have a massive warehouse, 3.5 hectares, and you need to provide all the stormwater management that you need and so on. So if you actually use that 3.5 hectare roof to actually manage your stormwater on the roof, you can buy a lot less land because you don't need to have the big the rain gardens, the retention ponds, and all these structures on the ground.
Yeah.
So that is one ROI. The other ROI is basically if you have a nice urban dwelling and you want to actually create a bar or something like that on the rooftop, that's another ROI.
Yeah.
And also the fact is that also whatever area you are in, and if you can reduce your at-grade stormwater solutions, you will save a lot of money. We had one case in Saratoga Springs that I'm aware of, where the project was, they basically found out at the end of the building procedures that there was something wrong with the stormwater calculations, and they did not really have space for a tank. And if they would build a tank, it would be a $900,000 US tank. So, and of course, the green roof did not cost that.
So there's your cost benefit.
So basically it saved the project, and it basically created a very clear ROI for them. So
that makes sense. And would that sort of be similar in every city globally, or do you see differences between the US and Europe? Or
depends a little bit. I mean, in a very, very you call it dicht besiedelt, very tightly densely lived city like New York City. That was really terrible English, pardon for that. Then you can of course see a clear ROI because the tanks underneath the buildings can be removed and something else can be used there instead. And if you're more in a countryside environment, and it'd be very easy for you to make a very lovely rain garden next to the house, I wouldn't even propose to use a purple roof concept system or detention roof.
The motives are completely different. Then it's about biodiversity or different.
Totally different situation. And also that's another thing as well. It's like there's no reason we cannot mix biodiversity with a purple roof concept system if you wanted to.
It goes hand in hand, doesn't it? I mean, Can you share some insights about the costs that are added to the construction work versus the payoff via savings? Like already questions by previous viewers.
Well, I mean, it goes by just this tank story, as I just told. That would be one saving that they managed to, one cost that they managed to avoid that was massive. Other than that, we're still looking into several warehouse projects where we are actually very much looking into what is the additional cost for load-bearing structures and so on. So this is something we're really looking into. But in reality, this system is so lightweight. So if you basically reduce some of the substrate and replace it with mineral wool, you have a massive load saving already there. So in the end, the water that is temporarily stored, it's basically in the live load budget, so it's equivalent to a snow load or something like that. Which changes the equations a lot when it comes to what extra load bearing structures do we need to add. But this is something we're looking into, and also has to be looked at from a case-to-case basis.
Yeah. So this is a question for the both of us, I think. So which type of clients are you having the best luck selling the blue, green, purple roof to, e.g. developers, office building owners? So we have a lot of conversations going on with project developers, but also companies, big companies that want to tackle the stormwater issue. And it's quite a diverse target audience, I would say.
Anyone in an urban setting that has a stormwater problem. Or even like in industrial parks. That's something that I encounter a lot. Really, really big companies who have massive building structures and are not that interested in digging big retention ponds. They are very interested in this in the purple concept system.
And also government organizations like municipalities are interested. In Amsterdam, you see a big change regarding this subject, and new build has to deal with this issue up front. So that's a great opportunity. A question from Diana. What about the cost benefits, or how the government are involved with grants in terms of the purple roof concept?
So I'm not really sure if it's meant with the research behind it, or if it's more related to the actual customer.
I think this is about the actual situation in a country. So in Germany or in the Netherlands.
So it's treated like any green roof, basically. So there's like the 1,000 Green Roof program, for example, in Germany, that you can apply for getting some grants to get started. So it varies so much from place to place, and I have very little knowledge in how these processes work, for example, here in the Netherlands.
It differs, but things are changing. For example, in Utrecht, they recently signed a covenant. The municipality is involved, where the idea is that from the beginning, green is involved in new build and renovation project, which is completely different from the past, where it could be an on top of a thing where in general at the end when the money is all spent, so the opportunities are growing rapidly. Do you know how many green roofs have been installed around the world since the first one? Andrew Rowley. Interesting question.
Too few. That's basically what I would like to answer to that one. I mean, if you looked at the first picture that I had in my presentation, you saw that it was just empty roofs there in such a dense area, So we should.
Well, I think you see them more and more, and people see them more and more. They are more visible. But still, if you fly in a plane over the country, and you can see the opportunity, it speaks for itself.
There's an unused roof area, basically, that nothing is being done to them. They're just standing there.
Question from Balas Erdei. What about those built urban environments where the sloping roofs dominate and there are not many flat roofs?
Yeah, that's a good question. We have tested the purple roof concept in our lab and modeled it very, very thoroughly up to 2.5% slope. So now we know it also works at higher slopes, but because we are scientists and engineers, we don't feel like we have enough data to very, very clearly state that how much and to add this to the modeler. So we need to run a few tests in the lab, but up to 2.5% we have given the all clear. And then as new data come in, we will absolutely up this percentage, and we will add that to the model as well to see, like, so you can see how the efficiency will drop with increasing slope, basically.
Well, we're focusing on sloping roofs as well. So we recently launched an initiative called Duo Roof, where on the south side of the slope you have your PV installation. On the north side you have your sedum, so you have a completely sustainable roof. So there's many opportunities.
Exactly. And those are retention-based green roofs. So they're like for those type of roofs, there is the sky's limit almost. almost wanted to say. But for the detention type roofs, for like the purple roof concept, we can only release the data that we feel comfortable with, that we have tested enough, because it's very important for us.
Yeah. Question from Donna Harris. How many green purple roofs are needed per kilometer in an urban city to make this workable? Could local councils install easily on existing buildings?
Installing on existing buildings? Yes, absolutely. No
definitely.
Problem.
Yeah.
We've had those. And to say exactly how many needed per kilometer is completely impossible to say, because it depends on how much green areas you have around and what the outflow requirements are.
Yeah.
So, but this is one of my favorite projects that I'm very much looking forward to, is a collaboration also with the University of Hofstra. We'll look at how the drop from the top, from the upper part of the building all the way down, and also include other green stormwater management solutions in the modeler as well, to see how you can upsize, downsize different solutions, and then get maybe even the whole, like going from just a building to city blocks, and even to full cities. So we'll be able to model this. But this is very big and very complex. So we are envisioning this, and this is absolutely the road that I personally would like to take a look at.
Sounds very interesting. Question from Gabrielle. What about the application in the Mediterranean climate? Is that something you...
Yeah, so the tension capacity of the roof is a physical process.
Yeah.
So it is completely irrelevant, really, if the plants are on there or not, if they're working, because the detention capacity will always work.
Yeah.
Now, for the Mediterranean climate, it's very important that you look at your climate, and you design the roof based on your climate, because I mean, of course, there are a lot of restrictions as well with regards to irrigation and such, and particularly in the Mediterranean areas. So there are most likely green roof experts where you live that you can discuss this with. Mm-hmm. But it's very important to take a look at mineral wool versus substrate and the combination thereof, and really take a look at some scientific data on longevity and irrigation and so on, so that you get the full picture before you start building anything. Because in the end, the roof is supposed to be there for the Rockefeller Center, the green roof there, built in 1920s. Still going strong. So this is a green roof should be designed for your climate and for your needs and the functionality that you require.
Yeah, there's a solution for everyone. Basically, that's the question from Rihanna. Will the extra load on the roof from the stored water require extra support material to be added to the building? So do you need to adjust the building in certain instances?
Generally, for this sort of standard new buildings, no. That tends not to be the case for this lightweight system. For a heavy blue-green system that is an intensive garden or something like that, then we're talking about something completely different. But if you think of the sizing of a sort of standard storm that you need to size for, then generally not. But of course, if you retrofit a building, you might need some extra help to carry the load-bearing structures. But it really depends on case to case.
Okay. Yeah. Thank you, Anna, for all these enlightening answers as well. And it's unfortunately we're running out of time, so we need to stop. If we haven't answered your questions, no worries. We will answer them after the webinar, and we'll send the recording of the webinar. Rest me to say thank you to all our speakers and to everyone who organized the webinar. We hope to see you soon. And for everyone, a good morning, good afternoon, or good evening from wherever you are. And have a good one.
Thank you.
Bye.
Bye.